Hi boys and girls, welcome to the 2-1 instructional video. Okay, in lesson 2-1 we're going to learn about terminating and repeating decimals. This is just the beginning of module 2. It's a bunch of vocabulary. It's quite a terrifyingly huge list actually. We're not going to pay too much attention to that. This is lesson 2-1. It begins on page 69. There are some vocabulary words over there: bar notation, integers, natural numbers, rational numbers, repeating decimals, terminating decimals, and whole numbers. We're going to talk about number families, and I'm going to teach you how to change a fraction into a decimal. Normally when you're in school, and we all have our little TI-30s, we use the FD button to turn fractions into decimals and decimals into fractions. But for right now, I'm going to teach you the 1960s version of how to do that, just because I don't know what kind of equipment you have at home. We're not going to be covering turning decimals into fractions in this section. That's not required of you, and no one's going to ask you to do that. So we're going to skip that part of this section. This section is going to go by very quickly. All right, so here we are on page 69 still. Learn rational numbers. When you first learned to count using the numbers 1, 2, 3, you were using members of the set of natural numbers. Sometimes people call those counting numbers. Counting numbers and natural numbers are the same thing. You know them because that's what you started with when you were, 3 years old and your mom taught you to tell how old you were. You were using the counting numbers or the natural numbers. Those numbers include 1, 2, 3, 4, 5, however high you could count. But if you add 0 to it, now you have a set called whole numbers. The only difference between natural numbers and whole numbers is 0. 0 belongs to the whole numbers, but the natural numbers were having no part of him. When you were a kid, you didn't start at 0. When your mom asked you to count to 5, you started at 1. Okay, nobody ever wanted 0 cookies, so 0 wasn't really a part of your childhood. But as you became older, you realized that sometimes 0 was a fact of life, and then we have the whole numbers. All right, whole numbers and their opposites make up the set of integers. So this would be 0, 1, 2, 3, 4, 5, 6, 7, all the way on, and the negative ones. Okay, so what have we not included at this point? We haven't included any fractions or decimals. All right, these are just whole numbers and their opposites. Once we get into fractions and decimals, then we're talking rational numbers. Okay, rational numbers are all the fractions and decimals. So let's see. A rational number is a number that can be written as the ratio of two. Basically, that means it's a rational number if you can write it like a fraction. And the top number and the bottom number are integers. Okay, you can't have a decimal in the numerator and call it a rational number. It has to be an integer. Right. Every rational number can be expressed as a decimal by dividing the numerator by the denominator. The decimal form of a rational number either terminates in zeros or eventually repeats. Repeating decimals are decimals in which one or more digits repeat. If the repeating digit is 0, then the decimal is a terminating decimal. So now this is a kind of a 2020 approach to this. Some people are of a mind that a terminating decimal doesn't really terminate, it just starts doing zeros, okay? Some people are like, no, it ends. Zeros are worth nothing, okay? And I'll show you the difference, and I'll explain how that goes here in a second. Repeating decimals, you know those ones. You put them in the calculator and you get 3, 3, 3, 3, 3, 3, 3 all the way across. Those are your repeaters. Sometimes more than one number can repeat. You might have 2, 5, 2, 5, 2, 5, 2, 5. Okay, that's still a repeating decimal. Bar notation is often used to indicate that a digit or group of digits repeats. The bar is placed above the digit or digits that repeat. For example, 0.83333 can be written as 0.8 with a bar written over just the 3. Not the 8. The 8's not repeating. You only put the bar over the number that repeats, the number or numbers. Okay, so there's some animation you're supposed to watch, but I've tried to show videos on these videos before and it doesn't work. So we'll just pretend we saw the animation and we'll go on. The animation shows that when a rational number is expressed as a decimal and the repeating digit is not 0, okay, this is your traditional repeating decimal, the decimal does not terminate. To complete the table, write each fraction as a repeating decimal. Then write each repeating decimal as a terminating decimal. If the decimal does not terminate, write does not terminate. All right, so I've pulled up this little janky active inspired calculator. This is, any old calculator can turn a fraction into a decimal. You don't need a TI-30. You don't need anything special to do it. You just need to know that a fraction is a little division problem. It is the top divided by the bottom, all right? Any fraction is, come on, pen. You gonna work for me today? The top number divided by the bottom number. Right? So in a calculator, you would type in the top number first, then you hit the divide sign, then you type the bottom number in second. Right? So coming over here to our little active inspired calculator, we're going to do 2 over 5. So we do the 2 first, the top, hit divide, and then the bottom, 5. 2 divided by 5, hit equals. That is a terminating decimal. That's all there is. It's 0.4. Now, they want you to write it with a repeating decimal. They want you to write all these stupid zero thingies. No. It's a terminating decimal. It's 0.4. Okay. Then we go over here. We're going to do 5, 6. Clear that off. 5 divided by 6 equals. Now we have a repeater. Okay, you see that 3 is repeating. And this little active inspired calculator, it only, shows up to about this point. It never uses this part over here. So you just got to kind of look at this. Luckily, your calculator, even on your phone, is probably way better than this. But this is going to be 0.8 with the 3 that repeats. So we're going to write 0.83, and then we're going to put the bar over the 3 to show that the 3 is going to repeat. All right? It is not terminating. Does not terminate. Still on page 70, they want us to look at these and classify them, okay? Does it terminate in zeros? That means it's a terminating decimal, it ends. Or does it not terminate in zeros? Does it keep going on forever and ever, okay? So this would be considered, over here, these are your terminating decimals. And these are your repeating decimals. They're just trying to make this really difficult and really wordy. Okay, so this first one up here, when we look at this number, we see that it ends in zeros, okay? A number that ends in zeros is a terminating decimal. It's actually just 0.64. We don't write all those dumb zeros. What's that? Here we have 0.56, but we have a repeating bar. That tells us that this number went 56, 56, 56, 56, 56. So this is a repeating decimal, 0.56, repeating. This one, they've got 42, 42, and then they did ... That's another way of indicating that that's a repeating decimal. Okay, so that is a repeater. It would be 0.42, and if you want to write that in bar notation, put the bar over the 42. The ... indicates that what you see going on here keeps going on. Okay. If you don't have the ... like here with this 0.84, that means that's all there is. That's all you're getting. That's a terminator. Well, not the terminator, but a terminator. Okay, this one, we got 0.333, and then the ... says this will keep on going like this. This is a repeating decimal and can be written as 0.3 with a repeat bar. Now, why don't I write 2 3s or 3 3s? No, if you have one number that is repeating, you only put the bar over one number. You only write one number. They're just being extra here, okay? This is a terminating decimal. It's just 0.7. That's all. That's it. Story over. It's a terminating decimal. Okay. Next. Okay, write fractions as decimals. Okay, so they want you to do 5/8. And they even wrote here, this means 5 divided by 8. And then they give you this long division lesson. I don't have time to teach you long division. Okay, you probably learned that in 4th grade or something. Go over to your calculator and go 5 divided by 8 and hit equals. And you get 0.625. That is a terminating decimal. That's all there is to it. And it ends right there. Okay. Now they go down here and they say, oh, the repeating digit is, and they want you to write 0, because after that it would be 0, 0, 0, 0, 0. And that's why we call it a terminating decimal. All right. Don't get confused by those repeating 0 things. I'm only going to give you fractions or mixed numbers and ask you to write them as decimals. That's all I will ask you to do in this lesson. And you can use a calculator. All right, -2/9. Well, we don't put the negative in the calculator. We know the answer is going to be negative. All the answers here are negative. They just want to know which one of these is right. All right, so let's just do 2 divided by 9. What would we get there? Now, the cool thing with 9s, and you're going to love this, it's pretty interesting, they are always repeaters, okay? And if you have a single digit over the 9, for example, if you have 1 over 9, you have 0.1 repeating. It'll just go 1, 1, 1, 1, 1, 1, 1. If you have 2 over 9, you're going to have 0.2 repeating. 3 over 9 is 0.3 repeating. And this goes all the way up until you get 8 over 9. The pattern continues. This would be 0.8 repeating. It's pretty cool. 9s are always repeaters. If you have a 9 in the denominator or a 3 in the denominator, it's always going to repeat. But that brings me back to our question, which one of these is correct? Well, this is clearly a repeating decimal. This 2 goes on and on and on. And looking at these solutions, there's only one C that indicates any kind of repeating decimal. So C was the correct answer because it's -0.2 repeating. Determine whether the decimal is a terminating decimal. This is repeating. Pretty fun, right? I think so. Moving on. All right, now I want to talk a little bit about mixed numbers, okay? Mixed numbers throw a little bit of a level of difficulty in there, but here's what you do. You don't ever worry about the front number. You don't ever worry about the whole number. It's just going to be the front, okay? This is going to be a decimal that starts with negative. Oh, come on, pen, pen, pen. It's just going to start with -1 point, all right? That whole number is always going to be the thing on the left. And then the 2/3, you go in the calculator and you go top divided by bottom. 2 divided by 3 equals. This is a repeater. Don't let the 7 throw you off. What the calculator is doing is it's rounding that last number. Because the next number would have been a 6, which is 5 or greater, it rounded the last number up. This is 0.6 repeating. So this would be written as -1.6 repeating. Now, they do kind of a proof to show you that what I'm saying is true. You can rewrite 1 2/3 as 5/3. Okay? And then they say just divide 5 by 3. Well, what would happen if we had done that? If we had done 5 divided by 3, would we have gotten the same result? Yes, we did. 1.66 repeating. So here, save yourself a step. You don't have to convert the mixed number to a fraction, okay? Just remember that the whole number would be on the left-hand side of the decimal, and then take that fraction, put that in the calculator, and that decimal gets written on the right-hand side, okay? The repeating digit is 6, okay? Okay, next. Okay, so again, here we've got 4 and 13/25. All right, so they've given us 4 and 13/25. So we're going to have 4 point. Just take that 4 and put it to the left of the decimal. Then come over here in your calculator and do 13, the top number, divided by the bottom number, 25, equals. And we get 0.52. Not 525252, just 52. This is equal to 4.52. Come on over here, and it looks like B is the winner. Is it a terminating decimal? Absolutely. It's 4.52. That's it. It terminates there. Oh, and for your video question of the day, you're going to need to know what my favorite food is. And it doesn't matter if it comes from Popeyes or KFC or Chick-fil-A, my favorite food is fried chicken. I love fried chicken. It's the best. Okay, so these are the only, well, no, I think there might be another page of these. This is pretty much what you're going to be asked to do for this section. The practice and the quiz will be no more difficult than this, okay? We're going to turn each of these into decimals. Now, with this one, we know this is going to be negative, so I'm just going to go ahead and start off by putting a negative sign there. I'm not going to bother putting that in the calculator. I'm going to do 11 divided by 16. So I come over here, 11 divided by 16 equals, and that's terminating, 0.6875. So 0.6875. Don't forget that negative sign. They put those in the problems, probably mess with you, thinking you'll forget it. Yeah. All right, 5 over 33. Okay, 5 divided by 33. Oh, there's a repeater. Look at that, 151515. So this is going to be 0.15, and the repeat bar's over the 1 and the 5 because the 1 and the 5 both repeat. Okay. Number 3, this is one of those whole number ones, so you're going to have 4 point, and now we take the 3/8 and we go over here and we go top divided by the bottom equals, and we get 0.375. So that goes over here, 375. And for this example, we put the -9 out front, we put the decimal, and then we're going to do 11 divided by 30. 11 divided by 30 equals, oh, that's a repeater. That's 3, 6 repeating. Notice the 3 doesn't repeat, but the 6 does. So we put the repeat bar just over the 6. Okay. Don't be confused by that 7. This calculator rounds that last number if it can. And so the next number would have been a 6, which is 5 or greater. So it rounded the last 6 to a 7. Don't be fooled. All right. These are the last 2 examples I'm going to do with you. All right. 1 pint is about 5/9 liter, right? 5/9 is a decimal. Well, if you remember my thing about nines, you know how this one's going to go. If you don't, it's okay. Any old janky calculator, even your great-grandma Betty's calculator, will do this one. 5 divided by 9 equals. And yep, it's 0.5 repeating. You can put the 0 in front if you want. I'm not a huge fan of the front 0. I write nice, big, bold decimals, so I don't really need it. But yeah, that's a repeater there. Again, the calculator, notice it rounded at the end. It made that last 5 a 6. Number 10, Phoebe won 7/16 of the competition she entered. Write 7/16 as a decimal. All right? 7 divided by 16 equals, that is a terminating decimal. And it is 0, if you want the 0, 4.375. Okay? So that is the only skill that I expect from you from this section, is to be able to take a fraction or a mixed number and write it as a decimal using any old calculator, even your great-grandma Betty's. Okay? You just do the top divided by the bottom. Remember, I like fried chicken, and head on over to McGraw-Hill and answer the special question for the video, and good luck on the practice.